Okay, let's talk about the way numbers can be presented. First way would be FLO, or floating decimal, and that's when a number just appears written out all the way, like this big long number with the decimal point over here. Another way is scientific notation. Scientific notation looks like this: 3 times 10 to the 8th, or in this case 6.02 times 10 to the 23rd. Scientific notation always has one numeral to the left of a decimal point, and then whatever power of 10 is needed to get that number to equal what it would look like if it was written all the way out. But another way to write numbers out, especially in a science or electronics class, is with engineering notation, also called metric notation. And here's some examples. 9 milli, or 37.32 capital G for gig, 14K, and you'll learn what those numbers mean. Here's some examples. A 5K run, 5,000. We don't walk around saying 5 times 10 to the 3rd run, or we don't say 40 times 10 to the 9th hard drive. No, it's a 40 gig hard drive. 128 meg for RAM. Let's take a look at moving those powers of 10. This should be review. If we look at a number like 4.02 times 10 to the 6th, an easy way to do this is to take the 10 to the 6th and realize that you're moving the decimal point 6 places to the right. You may have learned this back in, hopefully, middle school. 1, 2, 3, 4, 5, 6. That's where my decimal point's going to go. And each of these little troughs that I made would be another 0. Kind of write the number out again. It looks like it would be 4, 0, 2, 0, 0, 0, 0. And here's a real easy one. 3 times 10 to the 3rd. If you don't have a decimal point, you just have an integer here, for example, this is very easy because it tells you how many zeros to add. 3, just add 3 zeros. 3,000. How about a small number? Let's look at 6.71 times 10 to the minus 6th. Well, again, this tells you how many places to move the decimal point. So we start here, 6.71, and start moving to the left. 1, 2, 3, 4, 5, and 6. Fill those zeros in where the troughs were. Rewrite this number, 5 zeros. And I'll already show you that when I write these numbers out that are big long numbers, I'll take my 3 numbers at a time that make up the different places and then put a space in between. This is really easy on the eye to see 3 zeros here, then the next section, and the next section. Okay, here is a long floating number of zeros, and we'll do this to illustrate a point and make one nice, neat, compact picture of all the information you'll need for your engineering notation. To the right of the decimal point is the smaller numbers than 1, of course. To the left, integers. We already know the ones place, the tens place, the hundreds place. And what comes after hundreds? Well, you might say thousands, but in engineering or metric notation we call thousands kilos. So let's write kilo under that group of zeros. Bigger than kilo, well, think of RAM. We used to have kilobytes of RAM, now we have megabytes, M-E-G-A. And bigger than mega, think of the hard drive in computers, is gigabytes, or giga, G-I-G-A. Those are going to be the engineering or the metric prefixes for each of those groups. We'll say kilo instead of thousands, mega instead of millions, and giga instead of billions. For numbers smaller than 0, or smaller than 1, greater than 0, smaller than 1, because they're still positive, this first group would be called millis, and use a small m when you write out millis, M-I-L-L-I. 1,000 times smaller than millis is micro. You might have heard of microprocessor. That means the components in a microprocessor are 1/1,000,000th or 1 micro, 1 micron, 1/1,000,000th of a meter. And the next wave of technology, you might know the name of it, but would be possibly 1,000 times smaller than micro, and that is nano. And smaller than nano by a factor of 1,000. We'll get into this when we have to describe capacitors in electronics, and that group is called pico, P-I-C-O. Now what makes this easy is we will use the names of these groups whenever we're describing numbers, and we'll relate the names of the groups to powers of 10, like this. Kilos, which are 1,000, is 10 to the thirds. Okay, think of that. 10 to the third would be 10 with 3, or 1 with 3 zeros. That's 1,000. Megas, 10 to the sixth. And these will continue to be factored by a factor of 3, so you'll see, or 10 to the third, giga would be 10 to the ninth. Or a 1 followed by 3 zeros would be 1 kilo. A 1 followed by 6 zeros is 1 mega, or 1,000,000. Milli is 10 to the minus third. Micro, 10 to the minus sixth. Nano, 10 to the minus 9. And pico, 10 to the minus 12. We only have one thing left for this number line, and that is the abbreviations of all the prefixes. Giga, easy, capital G. Mega, capital M, and I'll ask that that center part of the M does not come all the way down to the line, like the sides of the M. Leave that center part up in the air like that, and that'll tell me that you've written a capital M. Kilo is a strange one. It should be a small k, and I have no idea why it isn't a capital K, but standard practice is to make that a regular or small k. Millis, small m, and there's where we can draw all three parts of the M on the same line. That's the difference between milli and mega. How about micro? What do we do now? We've already used the M for milli. So micro goes to the Greek alphabet, and we use the letter mu or mu. M-U would be the English spelling of the letter, and it just looks like a long tail on a cursive U. That's about what it looks like. Nano with an N, small n, and pico with a P, small p. Okay, this is what I call the number chart, and this should be on your first page of notes or on the inside cover of your notes, because you will refer to this a lot in electronics. Here's a look at the first practice page for converting numbers back and forth between floating notation, engineering notation, and what I call the calculator display, which doesn't usually have the K or the micro or the nano or the P or the G or the M there. It will normally just give you this factor of 10, and so we better talk about what that means. Let's have a look at our OGT calculator for a second. Okay, I typed in 25,000. We know that we would convert that to 25 kilo. And on the calculator, there's a button that says ENG. Well, that's a great button. That's your engineering button. In this calculator, for this calculator, it is green, so you have to hit the invert. Invert. There it goes. 25, and then it says an 03 here. But that 03 represents times 10 to the third. So 25,000 is 25 times 10 to the third, and we would take that times 10 to the third and call it kilo. Let's write it out. Look at it. $25,000. We know we can convert that to 25 times 10 to the third. And this times 10 to the third matches our number line right here, 10 to the third. So the whole times 10 to the third gets replaced with a K for kilo. That equals 25K. Simple as that. Okay, now you can do this visually, or you can use your calculator like I just did with the ENG button. Here's another calculator. You might see one of these. Let's do 6800,000. And looking at that, that's 6,800,000, or 6.8 mega. When I hit this button, ENG, it instantly converted it again. So you see 6.8 and then an 06. Some calculators will show the times 10 to the 06. Some will have an E06 there, but either way, you can understand it to be 6.8 times 10 to the 6th. Now that engineering button always converts these numbers to one of the prefix numbers that we did on our number line. In other words, it always converts it to 10 to the 9th, 10 to the 6th, 10 to the 3rd, minus 3rd, so forth. It's always one of those. So the 6.8 times 10 to the 6th becomes 6.8 mega. So very, very easy for this assignment to type in any number and just hit the engineering button and convert it from floating to engineering. How about a small number? 0.0000123. Okay? Hit that ENG button right here, and this time it reads 12.3 times 10 to the minus 6, and again you've got the number line memorized, and you know that 10 to the minus 6 is micro. So that's 12.3 micro. Okay, now what about not using the calculator? That's also very possible. Let's look at that same number, 0.0000123. Okay? And looking at that number, the first three zeros would be the milli group. Okay? The next three numbers would be the micro group. And you see you have 12 in the micro group. So 12.3, because this part is left over, 12.3 micro. Let's look at it, the milli group individually. What if I asked you to write 1 milli and write it out in floating numbers? What would it look like? Give that a try. Well, here's the answer. That equals 0.001. Did you put 0.1? You say, well, this is the milli group. What if I just put a 1 there? Well, if I asked you to write out ones, tens, or hundreds, you wouldn't put, for a number 1, you wouldn't put the 1 here, you'd put it here. If I asked you to write out 100, you'd go 100. So it's the same thing here. If it's a 1, it has to be all the way to the right. So there's 1 milli. If you wrote this, what did you really write? 100 milli. What would 10 milli look like? 0.01. Now, if you love that calculator, 0.01, hit the engineering button, 10 times 10 to the minus third, or 10 milli. So you can use the calculator, and you can just use good old sense here, writing it out, looking at the different groups. I would try to get in the habit of looking at a floating number and converting it without the calculator. That'd be great practice. Okay, let's look at this sheet then. And there was our first example. 0.01 is the given floating number. So we've converted that to 10 and little m for milli. And then for the third column, this is really easy. The 10 part is the same for these two columns, but milli isn't written on my calculator. It doesn't display on my calculator. It displays as e to the 03, minus 03. Some calculators, it might say just e minus 3, and some calculators won't have the e there, but I'd like you to put it there so there's no mistaking it. Can we look at 5.5k? Well, let's look at the number line and do this one. 5k, there's the single digit k's, there's the 5.5 would be over here. 5.5k. Do you see it? Let's use the calculator. 5.5. How do we go from engineering notation to floating? Well, when you need to put in kilos, micros, nanos, or picos, you use this button, the EXP on this calculator. Notice it brings up that same window that we had when it displayed 10 to the minus third or 10 to the minus sixth. And now we enter in that information for kilos, which is 10 to the third. So this calculator right now is saying 5.5 times 10 to the third. We want to display that as a floating number. Well, it depends on what calculator model you have. This one has an engineering button, which if I hit it in this case twice, it gets that exponent to read 0, 0. That means times 10 to the 0, which is times 1. Any number, by the way, to the 0 power equals 1. So that kind of takes the engineering notation away and just shows you what it would look like if it was written all the way out. So 5500, 5500. Does that make sense? 5500 is more than 5,000, and our number was 5.5k. Remember, k is like 1,000. And the calculator then again, just repeat the 5.5 part, and k is 10 to the third, so that'll be E03. You can put the plus there if you want. No point would be taken off for that. From this point, 250 e to the third. What I want to do here the first time is just take that e to the third and convert it. And look at your number line. E to the third kilo. So that is simply 250 and put a k there. Now how do we write out 250k? Let's do this one without the calculator. There's our kilos. How do we put 250 in that group? Well, left to right. 250, and then 3 more zeros have to come in there. 250,000. 250, 0, 0. Again, I like to leave that space between groups. It's really easy on the eye. Let's jump down to number 6. All the way to the right, 500 e to the minus 6. So from the calculator column to the engineering column, just repeat the number, 500, and now we change the e to the minus 6 to micro. Okay, 500 micro, and what is that going to look like if we write it all the way out? Oh, let's try another calculator this time. And I'll try this OGT calculator, which is maybe working. 500 micro. So again, I want to enter that in, 500, and when I enter in the engineering prefixes, I need either an EE button or an EXP button. And again, on this calculator, there's that EXP button. 500 micro is 10 to the minus 6, and when you do the negative exponents, you need this plus minus key to the minus 6. 500, and up there it says minus 06. Well, how do we get that into a written out number or a floating number? Now this calculator actually has right here in green FLO. That's our floating notation. So we'll try this again with the green button, the invert button, and floating. Oh, and then you have to hit equals and it works. And there it is, 0.3 zeros and a 5. 0005. 0.123 and a 5, like that. Well, let's look at that number using our number line right there. And now we come up here. So we have decimal point 000 and a 5. Wouldn't that be 5 micro? No, 5 micro, the 5 would be all the way over here. So when the 5 is here, it's 500 micro, just like this example here. 100 milli was the 0.1, not 1 milli. 1 milli is 0.001. So same idea here, 500 micro, that 5 needs to be there. I just wanted to show you one more calculator, and this is the TI. This is a good calculator at a reasonable price for what we do in electronics. Let's enter in a number, 0.0000526, just for an example, and we want to convert this number to some, but you can convert it to engineering notation from this display. It looks like right here, psi engineering. So let's go second to here, and look, you get to pick between floating, psi, and engineering. It's on engineering. Hit enter. Hit enter there, or just hit equals or enter again. 52.6, and very, very small display. It says times 10 down there to the minus 6. So 52.6, the engineering notation converted it times 10 to the minus 6, which is micro. What if you take that same number, by the way, and move it to scientific notation? It is 5.26 times 10 to the minus 5. And we don't like that in electronics because we don't have a name for 10 to the minus 5. That's one of the reasons we don't do scientific notation. We want to walk around and say 50 milliamps, not 5.0 times 10 to the minus fourth or whatever it is, milliamps. We want to be able to say the prefixes. Scientific notation allows you to get much more exact in your measurements and in your way of displaying your numbers. But for the most part in electronics, our measurements won't be very, very exact. They'll be approximate, and so the engineering notation is the best way to go. On this same calculator, if we want to enter a number in using the metric prefix, let's try that. Let's try 58. Sorry, clear that. Let's put in 58 mega. 58. Now how do we enter in mega, or 10 to the 6th? And in this case it's this little EE button right here in blue, so second EE. Now the other calculators, it said EXP. These calculators for Texas Instruments, EE. 58e to the 6th. So there's 58 meg. I've got my calculator set in scientific notation, so it says 5.8 times 10 to the 7th. We don't have a name for 10 to the 7th. Don't like that. And convert it back to engineering. And there's our 58 times 10 to the 6th. And we can go one further with this calculator just to double check if we're in a test or something and we had to write out floating notation. Move it over to floating notation, and look what it does. It converts that number to floating decimal notation.